Once again, I welcome students to my video lecture class on signals and systems. And in the last class, I did few problems on periodicity. And in that context, once again, I want to remind students, e power j theta, that is exponential, cos theta plus j sin theta, which is trigonometric. There is a relationship called, this relationship is what is called as Euler identity. So students of signals and system, from starting to the end, they have to very well remember this as Euler identity. E power j theta is equal to cos theta plus j sin theta. Okay, now in this class, I will work out problems on discrete signals. So these are the three problems I have given. State whether the following signals are periodic or not. Don't looking into sine and cos. Don't blindly come to decision that it is periodic. It is utterly wrong. So don't just by looking into sine and cosine, don't come to a conclusion that it is periodic. It may be periodic or it may not be periodic. State whether the following signals are periodic or not. If periodic, what is fundamental period n0? These are the three problems. I will show you now how to work out these problems. Number one, first, x of n is equal to 5 cos 0.2 pi n. Now, what is omega, angular velocity? In the case of discrete signals, we have to write like this. Omega is equal to 0.2 pi, which is equal to 0.2 pi, which is equal to 2 pi by n0. 2 pi by n0. Therefore, pi get cancelled. Therefore, what is n0? n0 is equal to 2 by 0.2, that is 10. Therefore, this is periodic because of periodicity we are getting n0 as 10. If we are not getting value for n0, then it is said to be aperiodic. So fundamental period is 10, hence it is periodic. So this is the answer. Next problem. I will take the next problem as x of n equal to 5 sine 2n. So what is omega? This is omega. Omega is equal to 2, which is equal to 2 pi by n0. Therefore, what is n0 then? n0 is equal to 2 pi by 2, that is equal to pi. So in mathematics, pi is irrational, square roots, and they are also irrational. n0 is pi, so its value is 3.143. But in discrete signals, the fundamental period has to be an integer, but it is pi. Hence, this function x of n is not periodic. It is not periodic. So don't blindly look into sine and come to a conclusion that it is periodic. It is utterly wrong. So condition you have to apply like this. So omega equal to 2 equal to 2 pi by n0. Therefore n0 equal to pi. It is not an integer. Now hence it is not periodic. So when it is not periodic, there is no question of fundamental period. So this is the answer. Now next problem, last problem. In the last problem, x of n is equal to 5 sine 6 pi n by 35. 6 pi n by 35. Now again write omega. Omega is equal to, for discrete signals you have to show this notation. It was this symbol for continuous time signals. Angular velocity is equal to 6 pi by 35. Now we know that angular velocity is equal to 2 pi by n naught. Therefore, what is n naught then? So n naught, pi get cancelled. We get n naught equal to 35 into 2 by 6. That is 35 by 3. 35 by 3, which is not an integer. But in this case, n naught can be made integer. You have to make one modification. As I said earlier, that multiples of 7, in one of my video lectures, I have taken multiples of 7 to get weekdays, 7, 14, 21, 28, etc. So now you modify this as angular velocity is equal to 6 pi by 35 equal to 2 pi into k. You make a modification. K is an integer. So you modify this as 2 pi k by n naught. Therefore, n naught is equal to 35 by 3 into k. So how to make this n naught integer? We have to take these values for k. If you take k equal to 1, 3, then 3 get cancelled, then we get 35. So we have to take multiples of 3. So k equal to 35 by 3, k equal to 3. So k equal to 3 means 3 get cancelled and n naught will be equal to 35. This is called as fundamental period. So n naught equal to 35 is fundamental period. If you take k equal to 2, sorry, not 2. If you take k as multiples of 3, that is 6. So then it becomes 70. But it is not called fundamental period. If you have to call it as a fundamental period, the basic number you have to take, that is 3. So 3 get cancelled, we get 35. Hence it is what is known as fundamental period. Now these are the 3 problems. In the next video lecture, what I will do is, instead of one function, I will take 2 functions. It is like this: x of t is equal to x1 of t plus x2 of t. x1 of t is periodic. x2 of t is also periodic. When we take 2 periodic functions together, then comes the question, what is the condition for periodicity? So there is a small theorem to be proved, which I will take up in the next class. Thank you.